Hi, on part 2 of volumes using of revolution, we're going to take a look at what happens if there's a gap. Now we're going to take a look here. We got the same function f of x, and then we have g of x down right below it. So let's say we still want to revolve this about the function, about the x-axis. This time, we're still going to go from a to b, but this time, my area that I'm going to be shading is only the part in between the two graphs. So when I draw my rectangle this time, it's still going to start from the very top. I drop it straight to the axis of revolution, but I'm going to stop here at g of x. That'll be solid. Anything after that is going to be open, and the reason for that is because if I revolve this whole thing, it's going to be kind of like a little donut. You're going to have a little hole there, a donut hole right there. Now, how does that affect my my disk? Well, I'm going to get on the outside the solid part. But then I got this part here that I'm also going to revolve. And if you notice, what we're going to wind up right here is a disk with a hole in it. Right there. A disk with a hole in it. We call this the washer method. So the question is, how do we find the area, the volume, using the washer method? Well, I just draw it out again. I draw a washer. Draw a cylinder with another cylinder on the inside. It still, in this case, will have dx for thickness. My axis of revolution is still my x-axis. But notice, I want to find the volume of only the shaded part. So I got to think back to geometry. Okay, so there's a little bit of much room here, but I'll take a look here. If you take a look, so it's not that bad. If I want to find the volume of the shaded region, just from geometry, I'm going to take the volume of the outside disk minus the volume of the inside disk. So I take the volume of the outside function minus the volume of the inside. And there's our equation that we're going to use. So the question is, how do we find the volume of the outside and the volume of the inside? Very simple. I need the radius of the outside. I need the radius of the inside. To get the radius of the outside, remember, we always measure from the axis of revolution. So I put my finger on the axis of revolution, and I go to the very outside function, which is this f of x. So the radius of the outside is going to be top minus bottom, f of x minus 0. In this case. To get the volume of the inside, same idea. Top minus bottom, so there's my inside. So right here, very simple. The outside is right here, and the inside is going to be like the hole. So the inside radius is going to be the top minus bottom, but that's g of x this time, minus 0. So when I want to find the volumes, they get the volume here, the shaded, it's going to be the volume of the outside, which is pi, times the radius of the outside, which is just f of x. So I get f of x squared times thickness, now minus the volume of the inside, pi. It's g of x squared dx. So when I simplify this, I'm going to get volume equals pi. I can simplify this. They both have a pi, and they both have a dx. So I'm going to integrate this to get them all from a to b. I factored out the pi, and what I'm left with is f of x squared minus g of x squared. And don't forget the dx. And there's our formula. Oops, sorry, that's terrible. Sorry. So let me go ahead and focus on that. There's our formula right here. Factor out the pi, and I'm left factor out the pi and the dx. That's my formula. Now I don't memorize. I can derive it every time, which you'll see in just a few moments. So we got this volume of this parabola, and there's our bound. So it's the same one as before. So I'm going to graph this one very quickly. It's 9 minus x squared. Again, we're only interested in the first quadrant, so that's not that bad. There's the region we're going to revolve. But if you notice in this case, we're going to revolve it about the line y equals negative 2. So that's down here. So I'm revolving this top half around this line y equals 2. I'm going to have a gap in there. I'm going to have a hole in there. So it's kind of like, imagine like a bagel, the top half of a bagel is what we're going to wind up with here. Very easy to kind of picture that. So when I drop, I'm about the line y equals 2, so I'm going to measure from my function to the axis of revolution. That's my radius. It's from the function to the axis of revolution. So what we're going to do right now is just to draw our radius from the function to the axis. This part's going to be solid because it's in the shaded region. This part's open, that's my hole. So remember, this right here is my outside function. This right there is my inside function. Set up your washer. Like so. It's dx thick. There's the line y equals -2. Be very careful. This is a little bit trickier. So now I want to get my radius of my outside function. Well, it's top minus bottom because we are vertical. On top is my parabola. It's this 9 minus x squared. But the bottom is not 0 this time. It's -2. So I got to subtract a -2. And if you simplify, we get 11 minus x squared. There's our outside radius. So as we move along, the radius of this function will be 11 minus whatever the x squared, whatever x is squared. So it's kind of easy to see right here. What if we're at 3? The radius here is going to be what? 2, because 3 squared is 9. So the hole has a length of 2 all throughout. To get the radius of my inside, see, there's my inside. Same idea. Now I go to the top of my inside function, which in this case is the line y equals 0. So it's 0 minus a -2, which is just 2. So to get the volume, like I said, to get the volume, it's going to be the volume of the outside minus the volume of the inside. There's my formula. Well, so it's basically we're just subtracting out the volume of 2 cylinders. Volume of the outside, pi times 11 minus x squared dx, minus the volume of the inside, pi times 2 squared dx. And now I'm just going ahead, they both have a pi in it, so I can factor that out. And I'm left with just the following, 11 minus x squared minus 4 dx. Because they both have dx, I factor over here. And then to get them all, I'm going to integrate it from 0 to 3. So let's take a look at it horizontally this time. Now our line is, now we're going to revolve it about the line x equals 2. So this is our axis of revolution. So if I draw out the figure again, the same figure as before. Here's our graph. That's the region we're going to shade. There's 9, there's 3. But this time we're going to go about the line x equals -2. So now, when I draw my my radius, or my rectangle, it's horizontal. So you may recall, horizontal means we are in terms of y. So I'm going to draw horizontally, dash, 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 dash. There's my inside. That's my inside. There's my outside radius. So I draw it out. It has a thickness dy. It is a washer because of that gap right there, that hole. Now there's our line, x equals -2. So ready? We got to find the radius of the outside. Be careful. It's horizontal, so it's right minus left. So it's going to be our parabola, but be careful in terms of y. But we already solved it before, so that's just 9 minus y. Right there, so it's going to be the square root of 9 minus y minus a -2. Or the square root of 9 minus y plus 2. There's my inside. To get the radius of the inside, remember, that's my hole. That's the hole right there, the radius of my hole. Right minus left again, but this time right's at 0. So it's 0 minus a -2. That makes this one really hard. A lot of people miss that. They forget the 0. Remember, alright, so find the volume. Volume is the volume of the outside minus the volume of the inside. So the volume of the outside, pi, times its radius, the square root of 9 minus y, plus 2 squared dy minus pi, again times 2 squared dy. To get them all, look at them all, they both have pi. You can factor that out. What am I left with? The square root of 9 minus y plus 2 squared plus 4 dy. And when I integrate now, we don't go from 0 to 3 this time. Remember, we're stacking them. Stack, stack, stack. And we're going to go from 0 to 9. And that's how you find volume right there. Very easy to do. All right, so that's how we do volume. So practice these. Okay, we'll see you later. Bye-bye.